Hi everyone. By now, we all got a brief understanding of transformers, transformer architecture, attention mechanism, encoder decoder architecture, and also we have got a glimpse of the encoder only models and the decoder only models. One of the decoder only models known as GPT. GPT-2 was introduced before it got all commercialized and we all got to know the popularity of ChatGPT, isn't it? So in this video, we will do a deep dive hands-on into one of the variations of transformers for text generation. Specifically focusing on GPT-2, we'll walk through a practical demonstration of using GPT-2 to generate text. Here's what you would gain from this video. Generating text is the task of generating new text given another text. These models can, for example, fill in complete text or paraphrase. So if you have an input once upon a time, it generates the complete text. Once upon a time, we knew that our ancestors were on the verge of extinction, and so on. Can we have our own model created that can generate text for us? Of course. Let's look at the demonstration. Now we will jump into the notebook and we'll do some hands-on. So what are the prerequisites and what are we going to learn here? The first step is to install all the required libraries. The second step is to load GPT-2 model and the tokenizers. And then we will look into the text generation techniques, a greedy search, beam search, and n-gram penalties to understand how we can implement such models. So let's quickly install transformers and load the model. We will use GPT-2 in this case, GPT-2 in Transformer 2. Transflow 2.1 for demonstration, but the API is 1-to-1, the same for PyTorch. So this is what is the transformer module that I'm getting it from the Hugging Face. We all have seen Hugging Face earlier, and if you go to their site, we will have an understanding that what are the types of modules that they have, right? So I'm not going to these links one by one, but I hope all of you have an understanding. So once you have the installation, you would be able to import the transformers modules like GPT-2 tokenizer and TF GPT-2 LM head model. I'm going to demonstrate each of them one by one as we go through the code demonstration. So first step is, as I said, installation, which is a necessary library, and then loading the GPT-2 model and the tokenizer. And the third step is generating text using greedy search. Why greedy search? We will start with the simplest text generation method, which involves selecting the word with the highest probability at each step. We will also look at beam search. The primary difference between greedy search and beam search is to improve the quality of the generated text, we'll use beam search, which considers multiple sequences and chooses the most probable one. All right. So n-gram penalties, we will look at the last stage. So first, what are we doing here? We are creating a tokenizer using a pre-trained model GPT-2. We have loaded the GPT-2 model, and next we are actually passing it to a pre-trained model GPT-2 with a pad token end of sentence token ID. So this takes some time and I'm not going to execute it right now, but as you can see that after execution it takes some time to load all of these, and it gives you this output that all the weights of TF-GPT-2 LM head model were initialized from the PyTorch model. Does that make sense? Okay, so with this, let's deep dive. So the first thing that towards generating text, we'll start by generating text using simple greedy search method. So as you can see here, we are importing this um, context of generating a conditions text. So we have this: I enjoy walking with my cute dog, right? And we are using these particular tensor TF for defining it, and then now we are generating text until the output length reaches 50. Yeah, so we are giving the input IDs and the max length as 50, and this is going to execute and generate a text. So you can see that I enjoy walking with my cute dog, but I am not sure if I will be ever be able to walk with my dog. I am not sure if I will be ever be able to walk with my dog, and I'm not sure if I. So it's like, repetitive, right? So we have generated our first sort of text using GPT-2. Congratulations. But the generated words following the context are reasonable, but the model quickly starts repeating itself, isn't it? And this is a very common problem in language generation in general, and seems to have even more so in greedy and beam search. So there are different papers by Vijay Kumar 2016 and Sao et al 2017. The major drawback of greedy search, though, is that it misses high probability words hidden behind a low probability word, as can be seen in our sketch above. So the word has, with its high conditional probability of 0.19, is hidden behind the word dog, which has only the second highest conditional probability. So the greedy search misses the word sequence the dog has. So thankfully we have beam search. We are kind of demonstrating a difference and also the advantage of one algorithm over another in text generation field. Beam search is improvement over greedy search, and it considers multiple possible sequences at each step and selects the most probable sequence. If you look at the code, it's pretty simple. I'm just using model.generate, passing the input IDs, max length, number of beams, and early stopping. And now we can see that the sentence get generated here, and it's much better. I enjoy walking with my cute dog, but I am not sure if I will be ever be able to walk with him again. I am not sure if I will be ever be able to walk with him again. I am not sure. So basically it has definitely reduced this sentence generation and multiple sentence generations. So let's try out these with no repeat n-gram size of 2. So now this can be also eradicated. So this is another technique which is refining the output with n-gram penalties. N-gram penalties refines the generation by introducing a penalty to prevent the model from repeating phrases, right? And this is basically another improvement over the beam search technique. So to avoid repetition, we can use n-gram penalties. All right. So if you look at this, beam search will always find the output sequence with higher probabilities than greedy search, but is not guaranteed to find the most likely output. So let's see how beam search can be used in transformers, and we can set number of beams greater than 1 and early stopping true, so that generation is finished when all beam hypothesis reach to EOS token. While the result is arguably more fluent, the output still includes repetition of the same word sequences, which is a problem. So a simple remedy is to introduce n-grams. Penalties that are introduced by Paulus et al. And Klein et al. The most common n-gram penalty makes sure that no n-gram appears twice by manually setting the probability of next word that could create a already seen n-gram. This is very much fundamental understanding of this complete text generation process through initial generation models like GPT-2. Obviously, today's LLMs are much more advanced than this, but yes, this gives us fundamental understanding about text generation. So beam output equals to model.generate, input IDs, max length 50, number of beams 5, no repeat n-gram size equals to 2. Now we can see that the output says, I enjoy walking with my cute dog, but I am not sure if I will be ever be able to walk with him again. I have been thinking about this for a while now, and I think it's time for me to take a break. Wow. So that looks much better after we added no repeat in gram size, right? So we can see that repetition does not appear anymore. Nevertheless, n-gram penalties have to be used with care. An article generated about the city New York should not use a 2-gram penalty, or otherwise the name of the city would only appear once in the whole text. Another important feature about beam search is that we can compare the top beams after generation and choose the generated beams that fits the purpose based, right? So in transformers we simply set the parameters num return sequences to the number of highest scoring beams that should be returned. So make sure that the num return sequences are less than equals to number of beams. So we can set the number of sequences greater than 1. We can have beam output model generate, input IDs, max length, number of beams, number of repeated n-gram size, number of return sequence, and early stopping. So all of these are some parameters that actually controls how the generation happens. And then we can actually have 3 output sequences running over a loop, and we can see that we are getting a lot of generation and good outputs here. So the first one, I have been thinking about this for a while now, and I think it's time for me to take a break. And then it says, I enjoy walking with my cute dog, but I am not sure if I will be able to walk with him again, walk with her again, and so on. So there is a variation with these outputs, and that's good. Let's look at another example, and I'm importing transformers pipeline and using text to text generation, and I'm passing question, what is 42? Context is 42 is the answer to life, the universe, and everything. Now the answer to life, the universe, and everything is what I am looking for as a generated text, and if I run it, I can see that the generated text, which is the primary goal, is to the answer to life, the universe, and everything. So we should see that um, the answer gets generated in this case here, right? So I'm looking for the generated answer for translation, which is English to French. I am very happy, and we can see this Jasus right, which is basically the translation of the same same question here, right? So with this, I think it gives us a very brief understanding of this text generation process, right? And I hope I will be sharing this notebook with all of you, so that you can get a better understanding of this text generation process, and also try some hands-on on your own. So we demonstrated text generation using GPT-2 in this video, and GPT-2 is one of the pioneer of GPT-3, 3.5, and 4 versions. And we started with a greedy search and improved the results using beam search and n-gram penalties. Finally, we compared multiple generated sequences to find the best one. This concludes our walkthrough. Thank you for watching, and happy coding.